Advanced Algebra, Chapter 5, Lesson 1, we're looking at quadratics, and in this video we want to look at the graph of the quadratic and what it looks like in some key points. So let's read this paragraph and break it down into its key parts. The graph of a quadratic function is what we call a parabola, and that's a U-shaped, and we'll show you that in just a moment. The axis of symmetry, axis, you know, the earth spins on an axis, or a basketball, it's kind of this imaginary line that goes through it. That has an axis of symmetry, and it's a line that's going to divide the parabola into two parts, and the two parts are mirror images of each other. What's on one side of the axis looks exactly the same as what's on the other side. The vertex of the parabola is a point at which the parabola intersects the axis. So the vertex is on this axis of symmetry. And that's going to be an important point moving forward, because when I want you to identify the axis of symmetry and the vertex, they're going to be the same. So because the point of the vertex is on the axis. The y value of the vertex of the parabola represents the maximum or the minimum. So again, we're going to talk a lot about this vertex point, and as we talked about earlier this year, these graphs that have this vertex, a point of max or min, is very important, because when we apply these functions to real-world data, we are usually looking for the maximum of something or the minimum of something that's created. So breaking this down then, the shape is a parabola. That's what the graph of the quadratic looks like, and that's a U shape. So this would be your standard or typical quadratic looking graph. There is the axis of symmetry, which divides the parabola in two, and so that each side is a mirror image, which is, you know, symmetry from art. You probably remember that. Now, the equation of this line, because it's going to be a vertical line, and we talked about these earlier, is always going to be x equals some number. So when we ask you for the axis of symmetry, it is a line, so your answer needs to be the equation of a line, and it's always going to be x equals that value, whatever it is. And this would be an axis of symmetry that divides this parabola. You'll notice that it's exactly the same on both the left side and the right side. Now the vertex would be right down here. Actually, I think I covered that in the next slide, so let's just go there. Yeah, the vertex is the intersection of the parabola itself and the axis of symmetry. So here's the parabola itself, the axis of symmetry divides it, and then right here where they intersect is the vertex. Now, it's a very important point here to make. Remember, this vertex has a coordinate, an x coordinate and a y coordinate. The x coordinate is the same as the value of the axis of symmetry. We talked about the axis of symmetry having an equation of x equals a number. Well, the number that equals is the x coordinate of the vertex, because the vertex is on that axis of symmetry. So something to keep in mind as we're moving forward. The y value, actually I think I talked about that on the next slide, so let's go there. The y value of the vertex represents the maximum or the minimum. So this vertex here, the x coordinate is the axis of symmetry, and the y coordinate is actually how high or how low that point is. Remember, the y-axis is the axis that goes up and down. So as you go up the axis, you're getting higher. As you go down the axis, you're getting lower. So as the height of the vertex changes, that will be the maximum or the minimum. Now I want you to notice, when is it a maximum and when is it a minimum? Well, it's a maximum if the parabola opens upside down, and so this point becomes the highest point of the graph. And you'll notice that when things open upside down, we'll talk about this more in our transformations, but that's that negative sign in front. So if there's a negative in front of the quadratic term, that y value or that vertex is going to be a maximum. If the parabola opens up, then that U shape, the vertex is at the bottom, so in that case it's the minimum value, and then again you have a positive x squared. Now, it's important information that I just want you to get, and actually I'll cover it on the next page. This kind of summarizes that. The max or the min is the y value of this vertex is on that axis. Now, a little bit of things to note, some vocabulary that's very important that you know. I want you to understand that the vertex gives us two valuable pieces of information, each one of them different, so you need to know which one is which. All right? The first piece of information is it gives us the number of the axis of symmetry. So it gives us the ability to write the equation for the axis of symmetry, where the axis is the vertical line and the x-coordinate is the line where that axis goes through. So the value of the x-coordinate of the vertex is also the value that goes in for the axis of symmetry. Okay. The second thing that the vertex gives us is the minimum or the maximum of the function, and that's the y-coordinate of the vertex. So the x-coordinate gives us one piece of information, the y-coordinate gives us a separate piece of information. You're expected to know which one is which. Right? Now there's a couple things that words that are very important when you're reading a word problem or something like that. When it says what is the maximum, I want to know what the y value is. So what means the y value? What is the maximum? What's the highest point? How high does it go? What is it? What's that number? When I say, well, where is the maximum or minimum located, I'm looking for the x value. You're going up. Well, if you go over to the x of 7 and you go up, you'll see the maximum is right there, or the vertex, or the minimum's right there, whatever. So very important to understand what means the y value and where means the x value when you're asked these questions in a word problem or in your assignments. Another thing to note then about your parabola is that because it's symmetrical, it has that line of symmetry that goes down. Each point on one side of that axis of symmetry has a corresponding point on the other side. It's mirror image. And those points are the exact same distance from the axis of symmetry. So if you have this drawing here, you'll notice that here's our axis of symmetry at x equals 2. And the vertex here is at 2, 0. And so you'll notice that every point on this side of the parabola has a corresponding point on this side of the parabola. And the distance from the axis of symmetry here to the point on this side is the exact same distance as the point from here to this side. So these distances remain the same. So whatever I go this way, x, and remember x is moving horizontal, y is moving up or down, so I go this far to the right in this point, and this far to the right I have this point, or to the left. So if I know the coordinates on one side, I can easily calculate the coordinates on the other side because the distance will be the same. So if from here to here is 2, then from here to here was 2, so the coordinate of this point would be 4, I'd go over 4, and then the y value would be the same, 8. Alright, so you'll be asked to do that as you tackle this homework assignment. Mirror the point, and because we have the same point, we're talking about the same point and its mirror, the mirror image is indicated with this little kind of like an apostrophe, and we call that prime. So Q prime would be the point that corresponds to Q on the other side of the axis of symmetry. So Q prime corresponds to Q and P prime corresponds to P. Alright, I'm going to do a couple of examples rather than do a separate video. I'll just do a couple of examples here. Watch as many as you need until you think you have it down, and then if you want to stop it, you can go ahead and stop it and tackle your assignment. But some questions you might run into are something like this. Identify the vertex, so that's one thing we have to do. Write the axis of symmetry, that's the second thing we have to do. And then list any points that are corresponding to P and Q. So we have 3 things that we need to do. So the first thing is we want to identify the vertex. So remember, the vertex is a coordinate, so I'm going to have an x and a y. So I simply find the vertex right here, and then I do the coordinates. Being careful to look at the scales because the scales will change. Here the scale is 1, so over 1, down 1, so my vertex is at 1, negative 1. Okay, the second thing it asked me to do was the axis of symmetry. And again, the axis of symmetry is always the equation of a line. X equals, and then it's a vertical line that goes through the vertex. So it would be, if I was to sketch it on here, a line that goes right down here. Now what's the equation of that line? Well, the equation of the line is x equal, and all you have to do is look at the x-coordinate of the vertex. It's going to be the same because that point is on this line, so it has to be a 1. The third thing then is to list P prime and Q prime. So the coordinate P prime, so here I'm up here, so if I go this far, then I'm going right over here, so this would be P prime right here. Its coordinate then would be, again, going from 0, 1, 2, 3 over, and then 1, 2, 3 up. So P prime would be the coordinate 3, 3. And then Q prime would be the coordinate, well, this one is this way, so there's a corresponding point right here. So that coordinate is 0, 0. Alright, so not too difficult, but those are a few things that you will be asked to do, knowing the vertex, where the axis of symmetry is, and then these corresponding points. So again, I'm going to do a few more. If you want to watch, go ahead. If you think you got it, then go ahead and stop it and go ahead and tackle your assignment. But I'm going to go ahead and do a few more. Alright, so let me get rid of those. Let's see. Okay, so same thing. We're going to do the vertex here. So here's the vertex. So the scale is still 1, so I'm -1 and up 2. So my vertex, again, it's kind of important to see where the vertex, -1 and then up 2, is to make sure you label what your answers are. So that's the vertex. We need the axis of symmetry, which again is simply x equals, and then whatever this x coordinate is, x equals -1, because that would be a vertical line right down here through -1. And then P prime would be, so from here to here, so going this way right here, so that would be 0, 1. And then Q prime would be, let's see, the distance from here and here, so this would be Q prime, so that's going to go -3, -2, so this would be -3, -2. Alright, I'm going to do another one. Again, as soon as you feel like you have it, you go ahead and stop the video, but I'm going to do a number of other examples. Okay, so here we have, let's see, the vertex is here. Now this one's kind of tough. Each one of these is 2, looking at the scale, 2, 4, 6. So about halfway would be 1. So that's going to look like 3. And it's going to be at 3, and then it doesn't go up or down, so that's going to be at 3, 0. The axis of symmetry again is simply the equation x equals, and then whatever that number is, so that would be 3, and again that would be a line right down here. And then 3, P prime would be, let's see, right here, so right about here would be P prime. We go exact same distance. That's 6, and this is 2, 4, 6, 8, and that's about halfway between, so that'd be 9. So I think that's 6 and 9. And then Q prime, let's see here, so that's going to be right here, so it's going to be 2, and then again about halfway between, my scale is 1, so that would be that one. Alright, do the next one. Crinking my neck there. If you're still watching, I doubt people are still watching now. I think this is pretty easy, but if you're still watching, good to see you. I don't really see you, but you know what I mean. Alright, so here's the vertex, and again, each of the scale is, this is a 2, 4, so that's going to be 0, 4. Alright, and then our axis of symmetry again is simply x equals whatever that is, 0, and again that would be the y-axis actually. Okay, and then 3 P prime, let's see, P here, so right about here, so this looks like over halfway, that's 1, then 2, 4, 5, so that looks like about 1, 5. And then Q prime going this way, right about here, so that's -2, and then up 2, 4, 6, 8, -2, 8, seems to be that. Alright, I think I have one more example I'm going to do, and again, if you're already finished watching, then I guess you won't see it, but if you do, alright. Okay, so vertex, again, right there, so that's going to be, the scale is 2, 4, so that's going to be -2, 0. Our axis of symmetry again is simply x equals whatever that is, that's -2, so that would be a line down here at -2. And then P prime, so that would be right about there, so it looks like -1. And this is still the same scale, 2, 4. So -1, -1 it looks like. And then Q prime would be over here. So it looks like -4, -4 appears to be that. Alright, so I think you get the idea there. I hope that was helpful, and that's what a quadratic looks like. Those are the main pieces of information that we'll be working with. So in the next video, we'll wrap it up by looking at something else. I don't know. There may not be a next video. I'll have to check. I'll get back to you.